Hello students, welcome back to HBK School. So myself is Kunal Pandya, HOD Physics Department HB Kapadia School and member of AAPT, that is American Association of Physics Teachers. So before starting lecture, I would like to say some important points. Important points are like this. There are 6 important points you have to remember before starting the lecture. Keep NCERT textbook with you, okay, while discussing this lecture. Okay, I would wish that you should keep a NCERT textbook with you so that you can note the important points with this highlighter and pencils. Okay, also keep a notebook with you so that you can write important points regarding this. Pause the video wherever necessary. It is not necessarily you have to go with the flow of video, but wherever necessary you can pause the video and note down the important points. Yes, finish the homework. This is very important thing. Finish the homework. Homework will be checked once the school resumes. Okay, as soon as the school starts, I will check the homework of each and every student. In case of any doubt, write in the comment section. Okay, without doubt you cannot understand physics. So if you have any doubt, okay, you should have any too many doubts, and all write all the doubts in the comment section. So as last time I have told you, they will start with Coulomb's law. Okay, so let's see Coulomb's law. First of all, let me show you the image of Mr. Coulomb. Yes, this is Coulomb, and he gave a law which is the very fundamental law. It is equivalent to Newton's law. Okay, Newton gave the law for gravity, in the same way Coulomb gave the law for electricity. Okay, the Coulomb's law basically is for electricity. Okay, it is for electricity. So Coulomb's law, what actually is Coulomb's law? Let me explain you. See, you might have seen such type of printers, such type of toners, such type of car paintings. Yes, you have seen this scene in how the cars are made, or how things are made in National Geographic Channel or Discovery Channel. So basically, when the car is painted, in that case also Coulomb law is used. So I will explain you how Coulomb's law is related with painting of cars and printers. So let's see Coulomb's law. What Coulomb says, if we have two charges, okay, imagine one charge is Q1, another charge is Q2. What are the charges? You are not knowing about something about charges, you should see my first video. So if there are two charges, they are separated by some distance. That distance should be finite and it should not be very large. So if there are two charges Q1 and Q2, distance between them is R, then in that case what Coulomb says, that force acting between them, yes, the electrical force will act between them, that force is directly proportional to the product of charge, that is, it is proportional to Q1 and Q2, and also at the same time, if F is inversely proportional to R square, it is inversely proportional to square of the distance between the two charges. Yes, some students might have reminded what gravitational loss is. In gravitation also we have two masses. Yes, F is proportional to m1 m2, and also F is proportional to 1 by r square. Okay, so same law is of Newton, same law is given by Coulomb, but some things are different, charges are different. Also it is inversely proportional to the square of distance between them. This is also inversely proportional to square of distance between them. So therefore Coulomb's law and Newton's law, both laws are said to be inverse square laws. Let's proceed further. So if charges are proportional to Q1 and Q2, and if F is inversely proportional to R square, if we combine these two equations, then we have F is proportional to Q1 Q2 by R square. So as if we know, when there is a proportionality sign, if we remove a proportionality sign, we have to keep a constant. In this case, the constant will be F is equal to, yes, K Q1 Q2 by R square. What is K? Yes, K is the electric constant. Likewise, we were having universal gravitational constant in case of Newton's law. F is equal to, we have G m1 m2 by R square. So in case of Newton's law, we were having G as a universal gravitational constant. No doubt there is no such universal constant here. It is just a proportionality constant of electricity. So in this case, we have K is equal to, the value of K is 1 by 4 pi epsilon 0. Here epsilon 0 is called the permittivity of the medium. Okay, epsilon 0 is called, it is the permittivity. So here epsilon 0 is called permittivity of the medium, and this F is equal to K Q1 Q2 by R square. We will be discussing about permittivity in later part of this chapter. So let's see some similarities and some differences are there in Coulomb's law and Newton's law. I have made a table for that thing. Let's see the table. Yes, in left hand side we have a gravitational force that is given by Newton. On right hand side we have electric force given by Coulomb. So what Newton says, the force act between masses. In case of Newton's law, or we can say the gravitational force, it acts between masses, whereas in the case of electricity, the force acts between charges. Okay, what are the charges? I have given a lecture for that thing. The gravitational force is a very weak force. Okay, we know that it is a long ranged force, but it is a weak force. Electricity on the other hand is a strong force. I have shown you experiment in my previous lecture that in which bits of paper were attracted with the comb. See, when the comb was held in the presence of gravity, of course, in that case the bits of paper were got attracted with the comb. In that case, the bits of paper were not falling due to the gravity. Okay, they were much more attracted to the comb. So in that case, we can understand that how the gravitational force is very weak compared to the electric force. Yes, the third line says that the gravitational force is a long range force. It acts up to an infinite distance, whereas in the case of electric force is a very short ranged force. In case of gravity, it doesn't depend on medium. Why? Because we have G, that is called universal gravitational constant. It doesn't depend on any medium, whereas in case of electric force we have a constant called K. It depends on medium. How it depends? Let me explain it to you. Imagine we have two masses. Let the mass is m1, another mass is suppose m2. If they are kept in bucket, on the other hand we have some charges q1 and q2. Let one of the charges q1, another is suppose q2. Initially the medium between m1 and m2 is a vacuum, okay, or we can say it is a free space. In that case, the force is given by F is equal to G m1 m2 by r square. Okay, this was there in chapter number 8 in 11th standard. On the other hand, I just explained it to you. When there are charges q1 and q2, if the distance between them is suppose r, in both the cases we have to take distance to be r. So if there are two charges q1 and q2, distance between them is r, then we can say that F is equal to k q1 q2 by r square. In this case, on left hand side, see, this G is called universal gravitational constant. In this case, K is just an electric constant. This G does not depend on any medium. See, if the name says it is a universal gravitational constant, it means its values remains constant everywhere in the universe. Whereas in the case of electric force, it is not the case. See, the case is not so. The K is equal to 1 by 4 pi epsilon 0. Where epsilon 0 is called a specific property called permittivity. If the medium permits, then only the force will act. Sometimes medium permits more, sometimes less. So the electric force acting between two charges will depend on permittivity of the medium. Okay, it is not the case in case of masses, because in the case of mass it depends just on the value of mass and distance. It doesn't depend on the value of G. See what happens if we fill these two buckets with water. See, initially the medium between mass m1 and m2 was just air. Now in this case the medium became water. So if the medium between the two masses becomes water, then the value of G will not change. Why? Because it doesn't depend on any medium. But if water is filled between two charges q1 and q2, so in that case the water will permit less or more depending on the situation. Okay, there may be some ions or something like that. So depending on the situation, it may permit more or it may permit less. In that case, the value of epsilon will be different, therefore the value of K will be different. As the value of K is different, force will be different. So my dear students, in this table, the last point, I think it's clear to you. It doesn't depend on a medium. This depends on the medium. Okay, so let's proceed further. Coulomb's law, I have explained it to you. Now let's see what NCERT says about Coulomb's law. It's one and the same thing, I know, but still we have to stick with NCERT. We have to follow. We are not supposed to lose the grip from NCERT. So what NCERT says about Coulomb's law? It says that the force between 2 point charges varies inversely as the square of the distance. It means F is inversely proportional to r square and directly proportional to the product of the magnitude of the two charges. It means F is proportional to q1 q2. See, have a textbook in your hand. See the theory number 1.6. you will be these lines are there in front of you. Take a highlighter or a pencil and underline these lines. Okay, so in this case we have f is proportional to q 1 upon r square, f is proportional to q1 q2. If we combine these two equations, then we'll have f is proportional to q1 q2 by r square. If we remove proportionality sign, we will have f is equal to k q1 q2 by r square. Let's see, this is the equation. F is equal to k q1 q2 by r square. So this equation is also there in our textbook. Take out your pencil and highlight this equation. Let's proceed further. NCERT have explained the same thing with the help of this diagram. In this diagram we have two charges. One charge is plus q, another charge is minus q. See the diagram in your textbook also. The distance between the two charges is r. See Fe here, E suggests that this is the electric force acting between the two charges. Okay, so in this case the force acting between the two charges will be F is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. How they have written 4 pi epsilon 0? See, we know that F is equal to k q1 q2 by r square, k q1 q2 by r square. What is the value of k? K is 1 by 4 pi epsilon 0. If we keep this value in this equation, we automatically get this equation. See, if F, we have a f over here is equal to, we have is equal to, instead of k, if we are keeping the value 1 by 4 pi epsilon 0, then we will have 1 by 4 pi epsilon 0 q1 q2 by r square, where k is equal to 1 by 4 pi epsilon 0. Here this value 8.85 into 10 is to minus 12 Coulomb square per Newton meter square. This value of epsilon 0, or we can say this is the value of permittivity. This value is for free space. This is for free space, or we can say it is for vacuum. Okay, if we keep this value epsilon 0, if we keep the value of epsilon 0 in this equation, okay, and above equation, we know the value of pi. The value of pi is 3.14. 4 itself is a value. So in that case we will get the value of k to be 9 into 10 raised to 9 approximately, and in numericals also you have to take the same value, 9 into 10 raised to 9 Newton meter square per Coulomb square. Okay, the unit of epsilon 0 and k will always be inversely proportional to each other. If the value of k is having a unit of Newton meter square per Coulomb square, the unit of epsilon 0 will be Coulomb square per Newton meter square. So I hope you have your concepts clear about this Coulomb's law in scalar form. Also we have some more equations to go. When the separation between two charges is much longer than the radius of each sphere, what this statement says? See, these are NCERT lines. If we have two spheres, okay, one of the sphere is having a radius r1, another sphere is having a radius r2. The distance between two spheres is suppose r. In this case, if the distance r is very much greater than r1, or if r is very much greater than r2, it means the distance between the two charges, suppose this is q1 and q2, the distance between two charges q1 and q2, that is r, if it is very large compared to the radius of each sphere, in that case we can consider these two spheres, this sphere number 1 and sphere number 2, to be point charges. So what is the condition for point charges? The condition is the distance between the two charges should be very large enough compared to their radius. So in this case also, if these two are considered to be point charges are q1 and q2, distance between them is r, then the equation will be f is equal to k q1 q2 by r square. The same equation will be applicable in this case also. Why? Because the distance r1 in r2 is very less compared to the distance between the two spheres. So now if the value of q1 is taken to be 1 Coulomb, if value of q1 is 1 Coulomb, see we have q1 is equal to 1 Coulomb, q2 also it is suppose 1 Coulomb, and if the value of r is also 1, if these three values are taken to be unitary, or we can say these three values are taken to be 1, in that case what will be the value of f? See, you can calculate yourself also, and I will also calculate it for you. F will be, what is the value of k? The value of k is 9 into 10 is to 9. q1, q2 and r are 1. So in that case we'll get f is equal to 9 into 10 is to 9 Newton. Okay. So if q1, q2 are taken to be 1 coulomb, and distance between them is also suppose 1 meter. In that case, the value of force will be 9 into 10 raised to 9 coulomb. So this was all about Newton's law, Coulomb's law in scalar form. Okay, we just studied all the things of Coulomb's law in scalar form. Now we will proceed for Coulomb's law in vector form. So let's see Coulomb's law in vector form. So like in the law of vector form in gravity, the same thing we have to do in this case also. Imagine suppose this is the x-axis, this is suppose y-axis. Let this charge be q1. The position vector of q1 with respect to origin is suppose vector r1. Let us imagine another charge q2. The position vector of q2 with respect to origin is suppose vector r2. Let this be the another vector. Let this be r21. Why we have writing r21? Because in this case vector is from r1 to r2. Okay, the third vector which I have drawn. Okay, it is from r1 to r2. In that case we have to write r21. In this case r21 is equal to r2 minus r1. So let's see Coulomb's law. We know that in scalar form we have F is equal to K Q1 Q2 by R square. This is the Coulomb's law in scalar form. Now as the force is vector quantity, on left hand side of this equation we have a quantity which is a vector quantity. We know that the force is a vector quantity. So force is a vector quantity. I have written F, vector F is equal to K Q1 Q2 by R square. Now tell me on right hand side which is the vector quantity. Think which quantity is a scalar on right hand side of this equation. So we'll find that K is it is just an electric constant. Q1 and Q2 are charges. Charge is a scalar quantity. Yes, vector R is a vector quantity, but when there is a square of a vector quantity, the square of vector quantity is always a scalar quantity. So to your surprise, on right hand side we are not having any vector quantities, but on the left hand side we are having a vector quantity. On the left hand side we are having a vector, on right hand side we are not having any vector quantity. So in such cases we have to take help of unit vectors. So we have to keep a unit vector. See, what is the magnitude of unit vector? See, unit vector by the name itself says that its magnitude is 1 unit. So on right hand side we have just a unit vector multiplied by this scalar quantity. So it will give the value of this scalar quantity itself, and also the unit vector is having a direction. The direction will get multiplied with this thing, so it will give the direction. So it's good to keep a unit vector in such cases. So let's see, force is a vector quantity. Force is from 1 to 2 or 2 to 1. We can take any one of the example. If it is from 2 to 1, force acting from 2 to 1, then we have to keep here 2 to 1. Okay, so remember, if this is the force is from 2 to 1, you have to take unit vector from 2 to 1. So it will give F21 is equal to K Q1 Q2 into R21, vector R21 upon magnitude of R21 into R square. This equation will first see, I wish you will write down this equation. So whenever I am there in the next slide, you can see this equation very easily. So write down this equation, pause the video and write this equation. Now let's proceed further. Yes, I have written in previous slide that F is equal to K Q1 Q2 by R square into unit vector. We have taken from 2 to 1. See, we have taken it from 2 to 1. This is 2 to 1. So we will write this is force from 2 to 1. Here we have to write 2 to 1. This is the unit vector. So in this case, force F21 can be given as F21 is equal to K Q1 Q2 by R square into, we can write this is R21 vector upon its magnitude. This is the basic definition of a unit vector. Unit vector is defined as the vector itself divided by its magnitude. So from that concept I am writing this equation. So F21 will be F21 is equal to K Q1 Q2 into R21. We can also write this R to be magnitude of R21. Some people might wonder how I have written this R21. I will tell you. Please be patient. See, the distance between two charges is considered to be R. See, this is charge Q1. See the diagram on right hand side. Yes, this is charge Q1, this is charge Q2. Distance between the two charges is taken to be R. So we have written this equation. See, you have written this equation. In this equation you have written R square. Why? Because the distance between two charges is R. Now when we are writing it in a scalar form of this vector, see what is the magnitude of this vector? If we see the magnitude of this vector, we can write magnitude of R21 is R itself. See, we are you can see this diagram. So from the diagram we can say that magnitude of R21 can also be written as R. So that's why I'm keeping this equation over here. So F21 will be KQ1 Q2 by R21 the whole square into vector R21 by vector magnitude of R21. So this equation will result into F21 is equal to KQ1 Q2. We can write this is R2 minus R1 divided by magnitude of R2 minus R1 the whole cube. So this is the Coulomb's law in vector form. So if some people are having difficulty in understanding this, I will give you the concept of 11th standard. If your 11th standards are clear, you can skip this video for 10 or 20 seconds. So this is the concept of unit vector. It was there in 11th standard. So I have written this is 11th standard concept. If we have two vectors, this suppose vector R1, another vector is suppose vector R2. So in this case, the third vector, if we draw it from the head of R1 to R2, then the third vector can be written as vector R2 minus vector R1. You have to see this head of this vector is towards R2, so therefore we'll write it is R2 minus R1. Basically it comes from law of triangles. Okay, those people who have their concepts clear about law of triangles can easily understand. Others can understand in this way. If we have two vectors, vector R1 and vector R2, if the third vector is from the head of the first vector to the another vector, then we have to see the head of this vector, it is towards R2, so therefore we have to write R2 minus R1. Likewise, if we have these vectors, like this is suppose vector A, this is suppose vector B, if this is vector C, then we can say that see the head of the vector C is towards B, so we have to start it from vector B, so it will be vector B minus vector A. Similarly, if this is vector P and this is vector Q, in that case the head is towards Q, so therefore we will write this is vector Q minus vector P. If the head is towards P, then we can write it will be vector P minus vector Q. So these were the concept of 11th standard. It was there in 11th standard. So again, let's see Coulomb's law in vector form. Once again, in super fast speed, this is x-axis and y-axis. This is charge Q1, this is charge Q2. Position vector of Q1 is R1, position vector of Q2 is R2. Let this be vector R. See, the head of this vector is towards R2, so therefore we can say this vector is R21. We have to write this R21 is equal to R2 minus R1. I think now the concepts are clear. So the force between two charges is F is equal to KQ1 Q2 by R square. If the force is from 1 to 2 and left hand side there is a vector quantity, so we have to keep a unit vector on right hand side. It will be from 1 to 2. In last case we have taken it from 2 to 1. Now let's take it from 1 to 2. So all concepts will be clear. So F12 will be KQ1 Q2 by R square. See what is R? R is R21, or we can say magnitude of R12. It is one and the same thing. It will be magnitude of R12 square into R12 upon magnitude of R12. So finally we can write F12 is equal to KQ1 Q2 into bracket vector R1 minus vector R2 divided by magnitude of vector R1 minus vector R2 the whole cube. So this law is said to be Coulomb's law. This is the Coulomb's law in vector form. Okay, now let's see the NCERT part. In NCERT, they have given this equation: F21 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R21 square. This equation is there in NCERT. Point out this equation, take your NCERT and point out this equation, make a box and remember this equation. F21 is equal to 1 by 4 pi epsilon 0 Q1 Q2 into unit vector R21 upon the magnitude of R21 square. Now some students might wonder that in this case, see over here I have written a vector. See, there is a vector in this case, but in NCERT they have not written the vector. So for those students I will say NCERT have clearly mentioned in 11th standard book somewhere that vector can be written like this. Okay, there are two methods to write or to represent a vector. Vector can be represented like this. We can write force as F, or we are supposed to write it in bold letters. So see, here they have written it in bold letters. So vector can be represented in two ways. It can be written bold, or it may be written with the help of a vector sign. So in this case they have written bold letters F21, so we have to consider it to be a vector. I am drawing just for your convenience. Okay, this is vector F21. It is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R21 square into R21. Now what is R21? Okay, this is a unit vector. Unit vector is defined as unit vector is equal to, it is vector itself, that is R21 upon magnitude of R21. If we keep the value of R21, what is the value of R21? The value of R21 is R2 minus R1. Okay, so if we keep this value, then we'll get, of course, the equation which we have written in previous slide. So this was the equation of Coulomb's law by NCERT. There is a diagram. See, I have drawn a diagram like this to explain it to you. Like this, we have seen this diagram. This was x-axis, this is y-axis. I have drawn a diagram like this. This is Q1 and Q2. A similar type of diagram is given in NCERT also. See, we have two charges. Okay, there are two charges. See, this is charge Q1 in the diagram and this is charge Q2 in the diagram. Also, you have to point it out in your NCERT. Don't spoil the textbook, but write it in a feasible manner. So this is charge Q1, this is charge Q2. This is vector R21. It is from R2 to see, once again I am saying that they have not written any vector sign because they have written it in bold letters. So in this case also, see, they have written the unit vector. Unit vector is equal to what? It is vector itself divided by its magnitude. This is vector R21. Similarly, they also have written R12. See, this one will be you will easily understand this thing. Also, there are the direction of forces. This is force Q1, this is charge Q1, this is charge Q2. If the two charges are positive, then they will repel each other. So repulsive force is given like this thing. See, they are repelling each other. And if one of the charge is positive, okay, here they have mentioned Q1 Q2 is less than 0. Here they have mentioned Q1 Q2 greater than 0. See, Q1 and Q2, when they are greater than 0, then Q1 and Q2, in this case we can say Q1 and Q2 both are either positive or they are negative. See, if both of them are negative, then also the product will be greater than 0. But if one of the charge is negative, another positive, in that case the multiplication Q1 and Q2 will be less than 0. If the multiplication is less than 0, it means one of the charge is positive, another is negative. In that case an attractive force acts between them. So therefore this Q1 and Q2, see, the direction of force is towards the charges. Okay, in this case it was away from the charge. In this case it was away. In the other case it is towards the charge. So see the diagram and understand it in better way. So let's proceed further. So this is the final equation given in NCERT. This is F21, force acting between 2 and 1 is given by 1 by 4 pi epsilon 0 Q1 Q2 by R square. This is the same equation I told you previously. So there is some similarity between Coulomb's law and Newton's law. In previous cases also I have explained it to you. In this case also, in Coulomb's law in vector form also there is some similarity. See, F12, okay, F12 is equal to minus of F21. It means if the force acting between 1 and 2 is in like this, in this direction, see, if this is the force acting between 1 and 2, okay, and this is what force acting between 2 and 1, the magnitude of these two forces are always equal. Okay, magnitude of these two forces are always equal, but there is a difference in direction. F12 and F21 both are having equal magnitude but opposite direction. So there should be a strike in your mind about Newton's third law. Remember that law? The action and reaction are equal in opposite, or we can say if the force acting between 1 and 2 and is equal to 2 due to 1, in that case the direction will be opposite. Thus we can say that Coulomb's law agrees with Newton's third law. Okay, Newton's third law states that if force acting on 1 due to 2 is F12, then force acting on 2 due to 1 will be F21. Both will be equal in magnitude. I am writing down over here F12, the magnitude of F12 will be equal to magnitude of F21. Both will be having equal magnitude, but the directions will be different. So thank you very much for this lecture. In next lecture we'll discuss about theory number 1.7, that is force between multiple charges. What happens if there are more than two charges in the system? Here we have discussed just about two charges, the force acting between the two charges. In next lecture we'll discuss about the forces between multiple charges. And also please note down your homework. In homework you have to do part B. Okay, part B of the worksheet. So in homework you have to do the part B of worksheet. Along with that you have to write the Coulomb's law in scalar form, Coulomb's law in scalar as well as in vector form. Okay, you have to write it one time. Okay, and try to finish part B of worksheet. It is not so easy. Okay, I understand you will be having some doubt in this part of worksheet, but try to finish those, and if you are having any doubt, please mention it in comment section. So this video was by HB Kapadia School. Thank you very much.